Alrighty, we are back. My voice is feeling a little bit croaky, but we will carry on. Okay, so today we are looking at the practice test. This is on scales, planes, and models. Alright. Shape 1. I'm not going to actually give you the answer for this one. I hope that you guys know it, but I think the thing that you need to make sure you are aware of with this is just that you give your explanation here. Alright. Give a reason for your choice. Okay, you can't just say that it is shape D. You need to explain why using the terminology from the textbook around the definitions of those shapes. All right, shape B, that's where it differs a little bit. You're able to just write here which shape above is a rhombus, and you just say shape A, B, or C, D. Okay, shape C is a cross section of which 3D solid. Now, it's important to remember that when we look at cross sections, that is to do with prisms. Okay, if it's asking for a cross section, it is to do with a prism. So we identify what sort of shape C is. So it is a decagon. All right, and then what you need to do is you look at shape C again. All right, so it is a decagonal prism. A bit of a mouthful to say, like we discovered in class yesterday, but that's all right. Name the 3D shape that would use A as a base. Okay, this is where it's important to distinguish. All right, it's asking you as a base. Generally, the 3D shape that uses a base is a pyramid. Okay, so it's asking you, all right, shape A as a base, it would be a pentagonal pyramid. Explain the difference between a prism and a pyramid. So what you are looking at there, you need to, it's asking you, it's 2 marks here. So it's asking you to tell me exactly what it is. So it needs you to tell me something about a prism and something about a pyramid. So you would say a prism has uniform cross sections throughout, whereas, and then explain how a pyramid differs. Okay, because that's that key point there, the difference. I'm not just asking you to tell me what a prism is and then tell me what a pyramid is not. Okay? And then the next one. This is that sketch perspective diagram. Okay? Now, my drawing is not going to be very great because I've got my pen and I don't have my ruler. But remember, we just got to follow the process. Draw that vanishing point. Draw our shape, our base shape, the focus. Draw some, lines over to that vanishing point. Identify a spot. Right. Needs to be shorter than these lines here. Okay, so we'll go here. We'll draw our shape. Obviously not accurate. And then we just embolden those lines. All right, the ones that are along here are dashes. All right, really important thing that is going to get you 4 marks. So obviously, if you do these things, you use the vanishing point, you follow this process, that's probably going to get you 2.5, 3 marks. The big thing that you need to do that will get you those full marks for this question is marking the dashes because all sides are equal. All right, mark those dashes, all sides are equal, and then on one of the sides, so either just down the bottom here or along the side where it's easy to read, you write the distance, 3 meters. All right, and that will get you 4 out of 4 for that question. In the faces in between the 2 ends are rectangles. What shape are all other faces? All right, so that's asking. So obviously these are rectangles. What are the 2 other shapes? They are triangles. The metal tubing for a frame costs $360. How much would it replace to cost 1 damaged edge? Okay, so that's asking you how many edges are on this frame and then divide it by this number. Okay, so if you go through and you count, there are 9 edges, all right? And we have 360, it's $360. So we can divide that. So 9 by 360 is what you would do, all right? Now, really easy way to just kind of focus on it and make it a bit simpler is just go 9 divided by 36. All right, that gives us 4, and then we'll bring that 0 back in, 40. All right, so it's $40 to replace. All right, and you write your answer. Therefore, $40 for a damaged edge. Bang. And that will get you 3 out of 3. Showing you're working out and giving me the answer. Alright, again, with this one, show the scale factor is 1000. Alright, so obviously it's a bit hard for me to do this on my screen, but I'm looking at this. I'm going to measure this bar here. Alright, I'm going to measure that first. Alright, I know that that is 2 centimeters on the page. Okay, so here, 2 centimeters is the equivalent to 20 meters. So that's what I would write here. 2 to 20 meters. Alright, 2 centimeters is worth 20 meters, but that's not how we write our scale factor. Alright, it's actually 20 meters is 2,000 centimeters. Okay, and we would never write this as our ratio because our ratio always needs to start with a 1. So we just simplify it, 1 to 1,000. Alright, therefore scale factor is 1,000. Okay, pretty simple. Excuse my messy handwriting, I'm just trying to get this done for you guys this morning. Alright. Tourist is standing at Ayres House and wants to visit the Adelaide Town Hall. If they only walk on footpaths along the roads, approximately how far will they need to walk to arrive at the destination? Okay, so for this one, you start here at the starting point. So the starting point is 12. And what you would do, you would get your ruler out and you would measure to the Adelaide Town Hall, which is here. Okay, so you would go, all right, the most direct route is from here to there. All right. You can go along these side streets if you want, and it's still going to add up the same, but just make use of your time and make sure that you just kind of do the straightforward one. All right. And I know that it equals 7 centimeters on the page. Alright, now I need to use it's going to get you 3 marks, so this is where you need to use your formula, which is actual length equals drawn times by a scale factor. Alright, so drawn is 7 times by 1000. Alright, I know that that equals 7,000. And I know that 7,000 centimeters equals 7 kilometers, so therefore 7 kilometres. The Adelaide Council decides to build a public car park that is less than 75 metres from the Adelaide Zoo, Torrens Parade Grounds, and the Botanic Gardens. Indicate on the map where it is best to build this car park to explain your reason why. Alright? Okay. So, a bit frustrated with that interruption there. You can blame Robert Haskett. What a shock that is. Just quickly, a correction with this one. It's not 7 kilometres, it is 70 metres. That is my bad. Okay, next they want to build a car park that is less than 75 metres from the Adelaide Zoo, Torrens Parade Grounds, and the Adelaide Botanic Gardens. Okay, so you pinpoint those 3 locations: Adelaide Zoo, Botanic Gardens, and the Parade Grounds. All right, and you need to indicate on the map where is an appropriate place. It needs to be within 75 metres of this location. All right, so a really simple one is to say, well, hang on, right here is in between all 3. All right, and that's how far it is. Okay, indicate on the map. So that's what I've done. Where the best place to build this, and explain your reason below. All right, for this one, guys, you just need to say that it is within. If you measure this out, it is within 40 meters of the parade grounds. It is within 30 meters of the Adelaide Zoo, and it is within 30 meters of the Adelaide Botanic Gardens. Therefore, it is the best place to situate it. Okay, this one here. Now, this is going to get a bit tricky for me because, I obviously can't do this on my screen, but I'm going to try my absolute very best to just use freehand. Okay, so a friend walks on a bearing of 210 degrees. Okay, so use an appropriate scale to draw an accurate drawing of this situation. So my scale is going to be 1 to 10,000. All right. There are 10,000 centimeters in a kilometer. If that makes sense. Actually, I think it's a bit more than that. Anyway, I'm not worrying about that. I'm just trying to get this done. So 1 centimetre equals 9 kilometres. Okay? So this is where they start. This is their starting point. I'm going to mark it up here because I know that I'm going 210, which is on this direction. It's just coming out here. All right? And then 98 degrees is coming out somewhere here. All right? So that's why I'm putting it up the top so that I can easily draw on my graph paper down here. All right? So they are going... Friend 1 is going 9 kilometres on a bearing of 210. Okay, again, this is not completely accurate, but I'm just going to draw a 9 centimetre line across there. I'm going to mark true north, and then I'm going to indicate that angle. I'm going to say this is friend A. Friend B, 98 degrees for 6 kilometres, so it's a little bit shorter. B. Again, same again. I'm just going to mark that as 98 degrees. That is fine. Obviously, with yours, you'll use your protractor and then use your scale as well. Make sure everything's drawn accurately, but roughly indicate that there. Okay, next one. Find the distance and bearing of friend B from friend A. So that is, make sure you understand this question, of friend A from friend A, of friend B from friend A. So from friend A to friend B is what it's asking you. All right. And I'll draw that little arrow. Okay, so with this one, we mark north on our A. Then what you do is you draw a straightish line, dashed line across here. You get your protractor out and you measure this bearing here. Okay? And that is roughly about, I'm going to guess it's around 70 degrees. All right? Again, not the answer, but this is what you would do. Okay? Then you would measure this distance, and let's just say that it turns out that this is 15 centimetres. I know that 15 centimetres is 15 kilometres. So I'll write 15 kilometres and 70 degrees. Again, not the exact answer. You need to be using your appropriate scale and making sure you're using the protractor correctly. All right? Give 2 reasons which might affect the reasonableness of your answer. Justify your answer. All right? You need to identify the 2. So it could be something like drawn length wasn't accurate. Could be something like protractor wasn't used properly. It could be something like I'm not too sure. Anyway, could be one of those 2 things, and you need to justify your answer. So suppose friend A accidentally walked on a bearing which is 10 degrees too large. Draw a line on your scale diagram in A to show the direction that they would have taken. Okay, this is where we come up here. Rather than 210, they've actually gone 220. Okay, so you would use a different colour here to indicate this, just so I'm well aware, and the marker is well aware that this is a different one. Okay, and I'm going to just draw it, again, not accurate, 220 degrees. That's how you do that. Then, if friend A stopped when they were directly west of where they should have been, friend B, how far away from their original destination are they? So what this is asking you, if they walk when they get directly west of their of the other friend, how far away are they from this distance? Okay, so this is where friend B is. Okay, directly west is exactly 270 degrees. All right, because that is, in a straight line across here. Like, north is a straight line, east is a straight line, south is a straight line. Okay, so 90, 180, 270 degrees. All right, so when they get to here, of them, how far away are they from here? If that makes sense. All right. Okay, that is how you would answer that question. You would measure that distance from, here to the original destination, to here, and that's it. Okay, that is the solutions for this test. It's pretty straightforward. Make sure you just take your time with your calculations and you'll be fine. All right, easy peasy. All the best.